Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from domain of functions. And in this session, we are going to find out the domain of this function f of x, which is equal to logarithm of x to the base x over 2, right? So let us see how we can find out the domain of this function using the definition of logarithms, right? So let us start. So now consider a function, say f of x, which is equal to a logarithm of say p of x, and here the base is q of x, right? And the valid values of x for which this function f of x is given by these inequalities, that is p of x must be greater than 0, and q of x should also be greater than 0, and q of x should not be equal to 1, right? So this function, that is logarithm of p of x to the base q of x, is defined in the set of real numbers only when p of x is greater than 0, q of x is greater than 0, and q of x should not be equal to 1, right? So here we have to find out all the valid values of x for which this function is defined. So now if we compare this function with this one, then here we have p of x is equal to x, and q of x is equal to x over 2. And if we apply these restrictions or these conditions, then we can obtain the domain of this function f of x, right? So now for this function to be defined for those values of x for which x should be greater than 0, right? And then we have qx greater than 0, so here we have x over 2 greater than 0, and q of x should not be equal to 1, so it implies x over 2 should not be equal to 1. So here we have these three conditions, right? So now from the inequality 2, we have x greater than 0, because if we multiply both sides by 2, we have x greater than 0. So now if we combine 1 and 2, that is x greater than 0 and x greater than 0. So here we have simply x greater than 0, and here we have x over 2 should not be equal to 1. So this implies that x should not be equal to 2. So here the domain of this function is defined when x is greater than 0 and x is not equal to 2. So let us now represent these two conditions on the real number line. So here we have the real number line, here we have minus infinity, here we have plus infinity. So now let us here plot x is equal to 0. So here we have 0 and 2 lies somewhere here, right? So x greater than 0 is given by this region, right? So here we have all the positive values of x except x is equal to 0. So here we cannot have x is equal to 0. So here we can now draw a cross, which implies that x is not equal to 0, and here x should not be equal to 2. So here we do not have x is equal to 2. So now if we combine these two conditions on this real number line, then we can easily write the domain. So the domain of this function f of x, it consists of the values of x which is from 0 to 2. So first we have this interval that is from 0 to 2, and remember here 0 and 2 are not included. And then we have the union here, then we have 2 to infinity, right? So all the valid values of x for which this function is defined is given by x belonging to the union of these two intervals, that is 0 to 2. So first we'll go from 0 to 2. Here 0 and 2, both the endpoints are not included, and then we have the union, and then we go from 2 to infinity. So this is the required domain of this function f of x.